guys, today we're focusing on reference nonfiction. So the first thing I need to make sure that you all have created in your notebook is, and you don't have to draw the lines, you can just start with the top and then we'll number them as we go. You have, from that last page, we created this in our notebook, our text features from A Black Hole is Not a Hole. So we're gonna be focusing on page number, text feature, and the purpose of each text feature. So make sure you have that right beside you and you have a pencil ready to go. So we're focusing on our reference nonfiction book today. They have a lot of features that help us locate and learn information. So today we're going to explore some of those text features. With the help of text features, we're really able to get such a better understanding of the text that we're reading. So we want to make sure to utilize those text features that we see. So let's go ahead and jump right in, friends. So the first thing that I notice right here at the top is the table of contents. So at the very start, we notice this important text feature. Let's add it to our chart. So on page V, we have the table of contents, and what it is going to do is help us identify key topics in the book and where they are located. So you can write that in your own words. You can pause, go ahead and write page V, table of contents, and the table of contents will help us identify our key topics in the book. Okay, moving on. We are now going to go ahead to chapter 2 because on Monday we actually read the intro in the first chapter, Places with Pool. If you haven't done Monday's lesson, go back and do that first. And today we're going to actually read the second chapter and tour some of the other features in the book. So, what text features do you notice on this page? What text features do you notice? Let's go ahead and add them to our chart. Okay, you probably notice a picture and the purpose, so go ahead and write that on your chart. The purpose of a picture is to provide us a visual image. I am able to look at this, read the words, and see what I am reading. Now, as we come on through to page 13, I'm seeing several text features. Go ahead and think and figure out what you see. Now, the first one I see is this title. And the title tells us what we will read about in this section. It's kind of like the main idea. So go ahead and add that to your chart. I also see a subheading that gives me a little bit more information. It says a black hole is an extreme gravity zone. So, wow. I took a stop and jot that said it must have a ton of gravity if it's an extreme gravity zone. Now, on our chart, we're going to add what is the purpose of a subheading? Well, it's going to give us more information. So we know that we're talking about the pulling and we know that gravity is going to be involved. Now, another thing I see on this picture is an illustration. It's kind of different than a photograph. I see this illustration, and an illustration is always just there to provide that visual image. So as I'm reading, you could actually go ahead and pause if you want and add in the title, subheading, caption, and illustration. And then you can kind of write what they do. They tell us what we're reading, they give us more information, they provide a visual image. I'm going to go ahead and get started reading. The pulling power of a black hole. A black hole is an extreme gravity zone. Gravity is the source of a black hole's super pull. You deal with gravity every day. You count on it to bring you back to the ground when you jump up. You depend on it when you try to catch a pop fly, knowing the ball will fall down. You expect it to be there, even when you don't even think about it much. People must have always noticed that objects fall, but they didn't always know what made this happen. They certainly didn't guess that falling objects had anything to do with stars, moons, planets, and the sun. But then one man came along with some new ideas. Gravity rules. That man was Isaac Newton. In 1687, he proposed that objects fall to the ground because Earth pulls on them. But his idea reached beyond Earth. He suggested that all things pull on each other, even when they are not touching. He considered this pull a force of gravity and referred to it as gravatas, what we now call gravity. So we see how that illustration that we added to our chart provided a visual image of gravity. Now let's read the caption that will give us some more information. Just outside a black hole's extreme gravity zone, its gravitation is still remarkable. In this artist's picture, a black hole pulls clouds of gas off a nearby star. Wow, that's pretty cool. Oh, there's the picture. I thought I was showing it to you. Okay. According to Newton, the force of gravity is a two-way tug between two objects. It works with anything, any matter at all. The matter can be a tiny bit of a thing, as small as a speck of stardust. It can be a huge collection of material as gigantic as a galaxy. It can be as rigid as rock or as flimsy as flame. No matter what it is, if it's made of matter, then it possesses the power to pull on anything else. Newton also noted that in any situation, the strength of pull depends on how much matter or mass is involved. When there's a lot of matter, there's a strong pull. Less matter means a weaker pull. For example, imagine a fluffy snowball and a harder packed snowball of the same size. The fluffier ball is made of less stuff. Its pull is wimpier than the pull of the densely packed ball. You can feel the difference when you hold the two snowballs in your hands. Each one presses down on your hand because of the gravitational attraction it shares with Earth. The hard-packed snowball has a stronger attraction to Earth because it is made of more material. It presses more forcefully than the fluffy one. It feels heavier. So here on page 14, we see a diagram. Could also be called a cutaway because it goes into an item or an insert. And this also helps to give us more information about important points. So go ahead and add diagram to your chart. Now, here we see Earth, and it's showing us how the pull is. The more matter, stronger, less matter, weaker. So that helped us kind of understand that on that page. Let's go on. Gravity works everywhere in the universe, as far as anyone can tell. It's gravity that holds the solar system together. Even faraway Pluto and Neptune, as well as the outer comets, are gravitationally connected to the sun. Instead of flying off into other parts of space, they stay in our solar neighborhood. The sun's gravitational pull extends so far out because the sun has a lot of matter packed into it. About 500 times the matter of anything else in the solar system combined. Even so, our sun and our solar system are just a tiny part of the universe. Most things are too far away to be swept in by the sun's gravity. Thanks again to Newton, we know that the closer things are, the harder they pull on each other, and the farther apart they are, the weaker they pull. So here we have another diagram, but I think on this one, we can focus on making sure we have this on our chart, and it gives us more information about important points. So it's really focusing on helping us understand gravity. This is true for all matters in the universe, including black holes. It's just that with black holes, the close-up effect is extreme. So here this kind of gives us some facts about matter. So sometimes you'll have an extra like fun fact or just more information about matter. Okay, so here we've got a diagram with labels. I love this. So add diagram with labels so it tells us exactly what each part is. So let's go ahead and read this page. An extreme case of gravity. Remember that super pulling space around a black hole? The one with the strongest pull in the universe? The super pull is the close-up gravitational power of the black hole. Here, in this zone, the gravity is so intense that nothing can move fast enough to fly, launch, jump, or zoom away. Around this extreme zone is a boundary called the event horizon. This boundary acts like a point of no return. Once past it, there's no going back. Only black holes have such extreme gravity zones, and only black holes have event horizons. This is what makes a black hole different from everything else. But a black hole is more than just a gravity zone, more than just an empty space inside an event horizon. A black hole also includes the source of its tremendous gravitation, a massive amount of densely packed matter sitting at its center. The matter is so densely packed that it forms a single point called a singularity. Where does this matter come from? How did it get to be so densely packed? And what does it have to do with the beginning of the black hole? The answer lies in the stars. So here's that picture describing the things that we just learned about. We see the singularity, we see the extreme gravity zone, and then the event horizon, the boundary of extreme gravity. So this cross-section diagram shows the anatomy of a black hole. At the center is an extremely small, densely packed singularity, super enlarged so that we can see it. Surrounding it is an extreme gravity zone, colored red, and the outer boundary is the event horizon. So make sure that we have that pictures with labels, and we want to make sure we have captions and our subheading that we see on this page on our chart. An event what? Have you ever watched the sunset? After it sinks below the horizon, Earth blocks your view of it. Even though you know it's still out there in space, you can't see it. Any and all events on the sun remain invisible for you as long as it's below the horizon. If the sun suddenly turned purple, you wouldn't see it happen. In a similar way, once an object enters the extreme gravity zone of a black hole, the object disappears from view. Even though nothing physically blocks our sight, once the object is beyond the boundary of the zone, we cannot see what happens to it. Events beyond the black hole's horizon are invisible to us. Because of this visual effect, scientists named the boundary the event horizon. So here's just a picture showing about how once the sun goes back, it's invisible to us. That's pretty cool, actually. Okay, so we'll talk about how a black hole starts at a later time, but I do want us to add a couple more things to our chart. I want us to add this timeline. We're going to read about it later, but timelines are a really important part that help us understand time. This is going to help us understand how black holes evolved over time. Okay, photographs, diagrams, and charts are really important to help us visualize. Okay, we also see this glossary that's going to help us define words. So that's another thing to add to our chart. And finally, let's see the index. This is going to help us get specific information without having to search through the whole text. I can go exactly to something that I want to read about. So that is all for today's reference nonfiction lesson. Keep going in in our slideshow, and you'll be able to make sure that you have all your notes. I'll have some at the end that you can copy down if you weren't able to get your notes. Great job. Now go and read some nonfiction. Love you.